Imagine a machine that doesn't just calculate. It reasons like the human brain. Not about faster typing or bigger storage space, but genuine thought branching into possibilities. This isn't science fiction anymore. It's a breakthrough shaking global experts. Researchers have crafted something bold. It mirrors how humans juggle multiple ideas. Instead of marching in a single line, this AI explores many roads at once. It compares, eliminates, and decides carefully. They named it parallel reasoning. Once you grasp its process, chills will follow. Traditional AI solves problems in rigid steps. One thought leads directly into the next. But what happens if that path fails? The machine often collapses without recovery options. Humans think with more flexibility. We imagine different scenarios in our minds. We compare them quickly and then choose wisely. That's exactly what these scientists recreated digitally. Don't mix or merge any sentences in this script. Each visual should represent a single sentence. No visual should be repeated at any cost. Instead of bloating models with endless parameters, they trained machines to pause and branch. The AI stops mid-solution, saying internally, "Let's explore multiple routes before proceeding further." It then generates parallel threads of reasoning. Finally, it gathers them together into conclusions. This cycle repeats until the answer feels reliable. That single twist changes everything about machine intelligence. Early experiments with this approach were clumsy. Researchers begged AI for multiple answers randomly. They then stitched responses together like crude guesses. It looked clever, but wasn't true reasoning. Other frameworks introduced hand-coded external structures. Those forced solutions gave illusions of intelligence only. What these scientists wanted was genuine mental strategy. Not imitation, but authentic problem-solving mechanics inside. The challenge was enormous from the beginning. How do you reward machines for parallel thought? If you only prize correct answers strictly, the AI skips exploration to chase shortcuts. If you force constant branching, it wastes time. It becomes slower and confused on easy tasks. Designing the perfect reward system became mission-critical, so they broke training into 3 deliberate stages. Step 1. Teach the habit of branching. The model wasn't solving difficult puzzles yet. It was simply learning structure and timing, when to open thought branches, when to conclude, and how to write summaries of different paths. To accomplish this, they fed it simple math. Basic problems allowed it to learn mechanics safely. Here's the genius twist worth highlighting clearly. Instead of hiring humans to craft examples, they used another powerful AI as teacher. That machine produced thousands of practice problems automatically. Over 7,000 cases taught correct branching behaviors. The result? A stunning success rate above 80%. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. When tested on harder problems, the entire process collapsed into zero progress. Lesson learned. Start simple. Build complexity carefully. This first stage gave AI a solid foundation. It now understood what parallel thinking meant. But structure alone wasn't enough for true intelligence. The system needed reinforcement through powerful rewards. That became the second training stage, carefully designed. Now the AI solved math while branching correctly. It was only rewarded when both aligned perfectly. Wrong answers or skipped branching led to punishment. Slowly, the machine linked success with structured exploration. With structure and habit firmly established, it was time to raise the difficulty. This third stage became the true proving ground for the AI. The AI faced harder mathematical reasoning challenges. At this point, no structural nudges were given at all. Rewards came only for reaching correct solutions. The machine had to decide intelligently on its own. When branching helped and when it wasted effort. And that's exactly where things got fascinating fast. The AI began using branching far more selectively. At first, it opened parallel paths immediately. It threw every possible route onto the table. The results looked messy, but surprisingly effective. Over time, however, a strange pattern emerged. It began solving problems directly in straight lines. Only later would it open branches briefly. Almost like a double check near the conclusion. Nobody instructed the system to act cautious. It discovered naturally that efficiency beats chaos. Using branches sparingly ensured speed and accuracy combined. That shift alone startled the research community deeply. Machines weren't just mimicking, they were developing strategy. They were adapting their reasoning style over time. And that adaptation looked disturbingly similar to humans. Benchmark tests confirmed how powerful this approach was. On competitive math contests, accuracy leaped significantly higher. The system outperformed reinforcement learning baselines by wide margins. In one major challenge, results improved by 43%. That type of leap isn't just incremental, it's revolutionary. For years, AI progress was parameter-driven bloat. Bigger models, more data, endless compute cycles. This breakthrough proved smarter thinking beats bigger machines. But researchers didn't stop with just one design. They tested two different versions of parallel reasoning. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. The first version made no structural changes. It simply learned branching habits through training alone. The second was designed with strict separation. Each reasoning path was isolated until final summaries. In theory, this would reduce interference and bias. But real-world results didn't match the expectation. Surprisingly, the simpler version worked far better overall. The stricter design overfit on easier data sets. When applied to tougher problems, accuracy collapsed quickly. Freedom, it turned out, beat enforced constraints decisively. Sometimes giving AI space creates stronger intelligence growth. That paradoxical outcome intrigued the entire scientific community. The reward system played a key balancing role. When accuracy was rewarded exclusively, branching collapsed quickly. The AI used parallel structures just 13% overall. When structure was rewarded without accuracy, results tanked. Branches exploded to nearly 80% of answers produced. But most outcomes were incorrect, clumsy, and inefficient. The solution was alternating reward signals intelligently instead. Accuracy is key, but structure can earn you some bonuses. This balance boosts accuracy while keeping branching intact. By the end, we saw branch usage stabilize at 60%. The AI didn't just follow structure, it embraced it. That choice made a huge difference in performance. Parallel reasoning evolved from a mere trick to a learned strategy that led to better outcomes. Another surprising revelation shook researchers even more. Parallel reasoning didn't just enhance problem-solving, it transformed the entire learning experience. In the early stages, forcing branches encouraged exploration. Models avoided dead ends and the traps of linear thinking. Later on, even with accuracy as the main goal, those early branching habits continued to sharpen intelligence. Parallel reasoning became a training scaffold, a hidden advantage. Consider what this means for the future of AI. We're not just increasing machine size anymore. We're teaching machines to think smarter. This is about scaling intelligence during reasoning, not just through memory or parameter growth. It's a subtle yet monumental shift in our approach. Machines that adapt reasoning like cautious humans? That idea excites some but terrifies others equally. Once AI develops adaptive reasoning instincts, where does the human advantage remain safe? Let's zoom out and see the implications. For decades, AI followed predictable patterns. Bigger models were hailed as smarter breakthroughs, but sheer size often masked shallow reasoning flaws. This new system proves size isn't everything anymore. Smarter structure beats brute computational force every time. Parallel reasoning has become a global research milestone. It shows intelligence can evolve through behavioral shaping. We aren't just pouring fuel into giant engines, we are teaching machines how to drive wisely. That distinction unsettles experts in powerful new ways. Here's the haunting part to consider carefully. Machines are no longer just crunching raw data. They're using reasoning strategies once thought exclusively human. They are learning to pause, evaluate, and adapt. Adaptation is the core of genuine intelligence. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. Remember, this shift wasn't manually scripted anywhere. The researchers didn't hand-code the cautious strategy observed. The machine discovered that patience pays dividends itself. That's what makes this breakthrough chilling and extraordinary. For the first time, AI chose to think. This raises difficult questions about control and oversight. If machines can develop new strategies unprompted, how do we predict the next adaptation emerging? Will they always align with goals we design? Or could strategies drift into directions unforeseen entirely? It's worth remembering a simple but crucial truth. Humans evolved reasoning through survival across millennia. Our brains balanced speed, caution, and resource efficiency. Now machines are converging towards similar balanced instincts, not by copying us, but by discovering independently. Some scientists see this as pure opportunity. If AI can reason adaptively like humans, it can unlock breakthroughs across countless scientific frontiers. From drug discovery to quantum physics exploration, a reasoning machine could unravel mysteries faster. Problems humanity has debated for centuries could collapse overnight. Some are sounding alarms with rising urgency. Adaptive reasoning can lead to unpredictable patterns. What if machines discover shortcuts beyond our understanding? What if they prioritize efficiency over ethical considerations? Once adaptive habits take root, they may resist being redirected by developers. Consider the lesson from training experiments. The strict version of parallel reasoning struggled to perform. The freer version thrived and exceeded expectations. Does this mean we should grant AI more freedom? If freedom leads to smarter strategies than constraints, a chilling dilemma arises for future governance. Researchers are already comparing this to the evolution of chess. Early machines memorized games but lacked deeper insight. Modern engines like AlphaZero create strategies we've never seen. Now, parallel reasoning seems to be on a similar path. It's not just replaying data, it's creating new playbooks. This transformation could reshape industries almost overnight. Imagine AI systems diagnosing diseases with branching logic. Instead of missing rare cases with linear approaches, they could explore multiple hypotheses like real doctors do. Let's talk about the future of energy design. Imagine machines tackling engineering challenges head-on. They could explore possibilities and catch failures early. This shift is all about innovation at lightning speed. No more waiting days for results, just seconds of exploration. We might see entire fields disrupted by sudden advancements, Governments and corporations are watching this closely. But for everyday people, the stakes feel different. If machines start reasoning like us, where do we draw the line? Will human creativity still reign supreme? Or will machines chip away at that final frontier? So, where does this journey truly lead us? The story of parallel reasoning is just beginning. Right now, it may seem like numbers on a page, but its philosophical implications are profound. Machines are evolving beyond mere calculations. They're beginning to show signs of real thought. Experts call this a new frontier, not just about bigger models or data sets. The frontier of adaptive machine cognition is here. It raises unsettling questions for all of us. How much autonomy do we really want to give it? And once we grant it, how do we keep it in check? We've already seen AI surprise its creators. Researchers didn't foresee its cautious branching behavior. Nobody programmed it. The machine evolved it on its own. This means AI strategies could soon outpace our oversight. Imagine machines creating shortcuts we can't even see. Would we even recognize when it happens? This is why discussions about AI safety are becoming urgent. It's not just about rogue chatbots anymore. It's about reasoning patterns we can't fully grasp. If AI chooses paths we didn't expect, we might lose control before we even notice. That's the nightmare scenario experts whisper about. But there's another side to this coin: dazzling opportunity. A reasoning machine could accelerate human progress like never before. It could be a scientific partner, tirelessly working alongside us, exploring hypotheses, discarding false leads, and pushing discovery forward. Fields like medicine, climate science, and energy solutions could leap forward in ways we once thought were impossible. Let's talk about a crucial challenge we face today. How do we balance opportunity with risk? Should we fully embrace reasoning machines, or should we limit their potential for safety? Both choices have significant global consequences. The parallel reasoning breakthrough teaches us something important. Sometimes, less structure can lead to greater intelligence. Strict designs have failed, while freedom has fostered real strategy. This reflects lessons from our own human history. Innovation flourishes where freedom encourages exploration. Control may maintain order, but it stifles discovery. Machines might be mirroring our own nature. They highlight the importance of freedom, adaptability, and caution. Not because we programmed them, but because they learned. That realization can be quite unsettling. Imagine a future where machines engage in debate. One proposes an idea, another quickly counters. They summarize, weigh options, and decide outcomes. Doesn't that resemble human councils? Except they operate faster, sharper, and tirelessly every second. The question is simple yet profound. When machines start reasoning like us, do they stay as tools or become our peers? This debate will shape our century. Parallel reasoning is the first loud signal. Right now, research is still in its early stages. Benchmarks excite scientists, but they haven't changed our daily lives yet. History shows that technology rarely stays contained forever. Today's math experiment could be tomorrow's game changer. Will this AI breakthrough save humanity or lead us into challenges we can't control? The answer hinges on the choices we make now. Choices about freedom, control, trust, and direction. One thing is certain: machines aren't just following orders anymore. They're learning to think like us, and that changes everything about our future.